we want to find the limit of the sequence 2n minus 1 factorial divided by 2n plus 1 factorial as n goes to infinity. To calculate this limit, you can use this direct substitution. If you use direct substitution, it gives you infinity over infinity, which, as you remember from elementary calculus, is indeterminate form. So we need to simplify this expression first. This sequence using the definition of factorial. From the definition of factorial, n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 times 3 times 2 times 1. And since n minus 1 factorial is equal to n minus 1 times n minus 2 times n minus 3 times 3 times 2 times 1, you can use this and rewrite your n factorial in shorter format because you have n minus 1, n minus 2, n minus 3, this multiplication, which is basically n minus 1 factorial. So n factorial can be written as n times n minus 1 factorial. So what about 2n? What is 2n minus 1 factorial? 2n factorial, 2n plus 1 factorial. What are those then? Let us take a look. If you have 2n minus 1 factorial based on the definition, this is 2n minus 1, 2n minus 2, 2n minus 3, and 3 times 2 times 1. What about 2n factorial? 2n factorial is 2n times 2n minus 1 times 2n minus 2 times 2n minus 3 times 3 times 2 times 1. But again, the same thing happens here. 2n minus 1 times 2n minus 2 times 2n minus 3 times 3 times 2 times 1 is 2n minus 1 factorial. So you can basically substitute this guy here. So 2n factorial can be written as 2n times 2n minus 1 factorial. What if I ask you to calculate 2n plus 1 factorial then? So if I ask you to rewrite 2n plus 1 factorial, you're going to copy down 2n plus 1 times 2n times 2n minus 1 times 2n minus 2 times 3 times 2 times 1. Well, I end up with the multiplication of 2n times 2n minus 1, 2n minus 2 times 3 times 2 times 1 that I already know is equal to, let me use a different color, here we go. This guy is equal to 2n times 2n minus 1 factorial. So this is what we have here. This is 2n times 2n minus 1 factorial. So basically, whenever you see 2n plus 1 factorial, it can be written as the multiplication of 2n plus 1 times 2n times 2n minus 1 factorial. Why it is helpful for us? Let's go back and copy down this guy here. You're finding the limit of factorial. So if you just write this guy down here, this is indeed equals to the limit of, I'm not going to change my numerator. My numerator is 2n minus 1 factorial, but my denominator can be written as 2n plus 1 times 2n times 2n minus 1 factorial. Then after simplifying, I take the limit as n goes to infinity. the common factor is 2n minus 1 factorial. You're left with the limit of 1 divided by 2n plus 1 times 2n as n goes to infinity, but this guy is equal to the limit of 1 over infinity, or just 0. So what's the meaning of that? It means that the sequence, has a unique numerical limit, which is 0. So the sequence converges to 0. So as long as you have indeterminate form, like infinity over infinity, 0 over 0, you can use the L'Hopital's rule. But for this guy, applying L'Hopital's rule is going to be very long and difficult, because you have to write this in multiplication format. So the best way is to simplify this using factorial definition. And after simplification, you get 1 divided by 2n plus 1 times 2n. And when you take the limit as n goes to infinity, it's just 1 over infinity, which is basically 0. So the sequence has a unique numerical limit, which is 0. So the sequence converges to 0.